Now we're going to look at a situation where we're going to expand a logarithm completely. And so we may have to take a few steps, but what we want to do is use our log rules, the power, the quotient, and the product rule, to separate things out and expand it as far as we possibly can. Starting with log of x cubed y divided by z squared. Okay, the first thing I'm going to do is notice that we have two things divided. And so the first step is to look at the quotient rule. Okay, so what we're going to do with the quotient rule is turn the logarithm of the numerator into one logarithm and then subtract logarithm of the denominator. Okay, and so now we've broken apart those two pieces into these two logarithms, again by quotient rule. Then notice that you have these two pieces, x cubed and y, side by side. Those two things are multiplied, and so we can separate them by the product rule for logarithms. So how that would go is we would put log of x cubed. Since they are multiplying, when I split them apart, that'll turn to addition with log of y. And then at the end we still have log of z squared. Okay, and so now we've split apart each individual x, y, and z term. There's one last thing we can do, and that's apply the power rule. And what it tells us we can do is take our exponents and move them to the front of each of the logarithms. And this is usually one of our last steps here. So we can expand this into 3 log x plus log y minus 2 log z. And that would be the fully expanded logarithm. Okie doke, and so here's another situation. Natural log of the square root 3x minus 5 all over 7. Again, we want to expand this logarithm as far as we can go. One thing I would do to begin is anytime you're dealing with roots in a logarithm, change them over to a fraction power. So the square root we would change to the 1/2 power. Okay, and now we're going to expand this logarithm. Notice that we have numerator and denominator. So what I'm going to use is the quotient rule on this step to expand it into 2 logarithms, one for the numerator, one for the denominator. So that would go natural log 3x minus 5 raised to the 1/2 power. Since this is the quotient rule for division, it breaks apart into a subtraction with the logarithm of 7. Then this 1/2 on top, by the power rule, we can move that to the front. And so this would change it into 1/2 ln 3x minus 5 minus ln 7. And that's as far as we can go when expanding the logarithms. We do have 3x minus 5 here, but because there's no multiplication or division, we're not going to be able to split that one apart any further. This would be as far as we can go. Now let's try the log base 5 of the cube root all over x squared y divided by 25. So kind of like what we did before, first things first, let's change that into the fraction power for the cube root. So that means I'm going to change this all raised to the 1/3 power. Now we're going to kind of work our way outside toward the inside. What's all over everything here on the outside is the 1/3. So the first thing I'm going to do is I'm going to move that 1/3 to the front of the logarithm via the power rule for logarithms. That would make it into 1/3 log base 5 of x squared y divided by 25. Okie doke, and now we're done with the first step, putting that there. Notice we now have the division. That's the next part to get to. from working our way outside in, we can now use the quotient rule. So that would change it into 1/3 times log base 5 of x squared y. That's the logarithm for on top, minus logarithm base 5 of 25. Notice that I'm keeping the 1/3 in front of everything since it was out in front to begin with. Then notice you have an x squared y together, and those are multiplied, so the next step is to use the product rule. So that would break it down into 1/3 log base 5 x squared plus log base 5 y minus log base 5 25. Okay, so now again we're breaking apart each individual logarithm step by step. The very last thing we can do is we do have this power of 2 above x. I'm going to go ahead and move that to the front with the power rule. We'll get 1/3, and so then that would change to 2 log base 5 of x. Then we have plus log base 5y minus, and this last piece that we have here, do we know possibly what number log base 5 of 25 is equal to? Indeed, we know the power that goes with 5 to get to 25. That's 5 squared, so that would change into just a 2. So you might make note of that's because 5 to the second is 25. That's why we're getting the 2 here. Okay? We just need to know the power for the 5. So fully expanded, this would be what we would get from the first logarithm that we started with. So here are a few practice examples to try on your own. So please pause the video here. Try to see if you can expand these two logarithms out. When you start the video back up, I'll go ahead and show how they're done. On the first one, what we're going to use is the product rule to split these into two separate logarithms, one for the 31 and one for the x squared. That would change it into log 31 plus log x squared. And since this is a power here inside the log, I'll go ahead and move it to the front. So fully expanded, this would go log 31 plus 2 log x. This one over here has division. So that's going to involve the quotient rule. We take the natural log of what's on top, and then since it's division, it'll turn into subtraction with ln of z from the bottom. Now the x and the y squared are multiplied together, so I can split those apart with the product rule, ln x, ln y squared, minus ln z. And the last step would be to move this 2 to the inside to the outside of the logarithm. ln x plus 2 ln y minus ln z.